What is up, math superstars? In this edition of Mr. Peterson Presents, we're bringing to you strategies to be successful with one-step equations. So in how to solve, let's give you some steps here. Step one is the goal is to isolate the variable, which means that at the end, we want to have the variable on one side of the equation all by itself. The way we do that is we do the inverse operation. So for inverse operation, we're dealing with the opposites. And so if you realize that addition is happening to your problem, what you want to do is you want to subtract from both sides. And if you notice that, and it goes both ways, by the way. So if you notice there's subtraction, you have to add. If you see that you have to multiply, you guessed it, you should divide. And this goes the other way also. So if you notice that you have division going on, you want to make sure that you're going to multiply. And so in doing inverse operations, whatever you do to one side of the equation, you have to do to the other side. Let's deal with some examples here. And so we have x plus 4 is equal to 6. And the deal is you have to show the one step of what you're doing. And so here we're going to go ahead and subtract 4 from both sides because we realize that we're adding 4 in the equation. What you have to do is you have to bring the variable down. So you have x, bring the equal sign down, and then you're going to do 6 minus 4, which gives us 2. And the good thing is that if we were going to double check our work, we would, if we said x is equal to 2, just like how we did replacement values, we check our work. So the original equation was x plus 4 is equal to 6. We do the replacement value, so 2 is x plus 4 is equal to 6, and we know that 2 plus 4 is 6. These check out. So if you know they check out, then you know you did your one step properly. Let's take a look at some other examples here. Here we have the variable on the right side, and it's the same exact deal. And so we notice that we are adding 12. So the goal now is let's go ahead and subtract 12 from both sides of the equation. We're going to bring our variable down. We're going to bring our equal sign down, and then let's go ahead and do 22 minus 12 is going to give us 10. And so we know that C is equal to 10. If we were going to double check it, we would fill in 10 for C. We know that 10 plus 12 gives us 22. So now what happens if we have the decimal? It's the same exact deal now. And so we notice that if there's no sign in front here, we notice that we have a positive 0.7. So let's go ahead now and subtract 0.7 from both sides. Let's go ahead and make sure our decimals line up here. Let's go ahead and bring down our variable x, bring down our equal sign, and let's go ahead and subtract these now. So let's add our 0, and you can see I'm just subtracting away here. So I'm left with 2 and 57 hundredths. If I was going to go ahead and fill this in, if I was going to go ahead and add back 0 and 7/10 back to it, I know that I have 3 and 27 hundredths. So now let's deal with when we have subtraction. You guessed it. Opposite of subtraction is addition. So let's go ahead and add 5 to both sides of our equation here. What we're going to do is we're going to bring our variable down, y. Let's go ahead and bring our equal sign down, and then let's do 12 plus 5 is going to give us 17. And the way we check is that we fill in 17 for y. We know that 17 minus 5 gives us 12, so we know we did our work properly. So now we have d minus 6 is equal to negative 10. So you notice that we can also have negative variables, negative integers in here. So let's go ahead and add 6 to both sides of our equation. Let's bring down d, let's bring down our equal sign, and then negative 10 plus 6 is going to give us negative 4. And the way we go back and double check, we have negative 4 minus 6. If If I go and add the opposite, we know that that equals negative 10. So we did our step properly. So now what happens if we have fractions? The same exact thing. We notice we're subtracting 1/8. Let's go ahead and add 1/8 to both sides of our equation. Let's go ahead and bring our variable down, the easy part. Bring our equal sign down. And we know when adding fractions and subtracting fractions will make common denominators. And so 3/8 is the same as 3/4 is the same as 6/8. 6/8 plus 1/8 gives us 7/8 here. And I know that if I was going to plug it in for x, 7/8 minus 1/8 is 6/8, which is the same as 3/4. Now let's deal with multiplication. And when I multiply, the inverse operation is division. So the way this is going to look is that I'm going to write this as a fraction, and I'm going to divide both sides by 2. The way this is going to work is that 2/2 simplifies to 1. So I don't have to rewrite that. I'm just going to go ahead and bring my variable down p, bring down my equal sign, and then I'm going to do 18 divided by 2, which is going to give me 9. If I was to fill this back into the original equation, 2 times 9 for p is obviously equal to 18. So now let's do this one. So I have negative 3x is equal to negative 21. So we're going to set it up as a fraction, and we're going to divide both sides by negative 3. Let's go and bring our x down, bring our equal sign down, and then negative 21 divided by negative 3 is going to give me positive 7. And the way I check, negative 3 times a positive 7, a negative times a positive is going to give me this negative 21. So now we have 9 is equal to 2y. Let's go ahead and divide both sides by 2. The 2's cancel out, so I'm left with y. So I'm bringing that down, bring down our equal sign, and I'm actually going to leave this as an improper fraction, 9/2. If I was going to go ahead and double check this, I know that 2/1 times 9/2, if I'm going to cross simplify, is going to give me 9 as a whole number. So now we got this one. I have negative x is equal to 33. You notice that there's no integer in the front because it's not listed, because it's actually negative 1 here. So what I'm going to do is I'm going to go ahead and divide both sides of my equation by negative 1. What happens is the negatives cancel out, so I'm left with x being equal to negative 33. The way this looks is if I check this, so if I have negative x, I'll have negative 33, and a negative times a negative gives me that positive 33. So now I got division, and here's the way that division looks. So I have 3 is equal to x divided by 5. What I'm going to do is I'm going to multiply both sides by the denominator, which is going to be 5. So in this case, it's same as 5/1, which means that the 5's will cancel out each other. They both become 1's. So I can just bring down my variable x, bring down my equal sign, and then 5 times 3 gives me 15. The way to double check, 15 divided by 5 will give me 3. And what about this case? So what you see that I have x divided by negative 5 is equal to negative 10. Let's go ahead and multiply both sides by negative 5. I'm using parentheses here just so I don't get confused and think that the right side is going to be subtraction when it's actually multiplication. But I'm going to go ahead and divide both sides by negative 5. The negative 5's cancel out, leave me just with x being equal to negative 10 times negative 5 gives me positive 50.